Hello, Kampala Junior Academy. You are most welcome to today's lesson. My name is Kimuli Robert. I'm going to teach a subject that is very important for your life. And remember, this subject is so interesting. That is, if you are very attentive. Now, what you should do is, first of all, clear the environment. It should be very free from any disturbance. If you have the young ones around, please you keep them away. And at this time, you should get prepared. You get where you're going to note what I am going to teach. And you should be very, very attentive. Otherwise, today we are going to look at addition of bases. But remember, let us look at operation maybe. We shall combine two. So we are going to look at operation of bases. And in that, first of all, we are going to look at addition. And we shall also look at subtraction. So now, straight away, I take you to what we are to look at today. We are going to look at addition of bases. So we are going to look at addition of bases. But remember, before we look at addition of bases, this is what you should know. Each base has got digits used in that particular base. For example, in base 2, the digits used in base 2 are 0 and 1. And the digits used in base 3 are 0, 1 and 2. The digits used in base 4 are 0, 1, 2 and 3. Now you realize that a digit equal to the base cannot be used in that particular base. Neither can we use a digit that is greater than that particular base. So now, this is our first example. Examples. Examples, number one. Number one is add 225 base 6 plus 434 base 6. Now when you look at this question, you realize that the digits used, you don't have a digit 6, because if you write 6 in base 6, that will be a wrong statement. We cannot write 6 in base 6. Neither can we write a digit that is greater than 6 in base 6. So now let us add. This is a solution. Please, you need to be very, very attentive. So we are adding. So I am going to arrange that is vertical. So that is 434 base 6. And this is base 6. So we are going to add. It's addition. But now remember the digits used in base 6. Let me first note the digits that are used in base 6. The digits used in base 6 are 0, 1, 2, 3, 4, and 5. Those are the only digits that are used in base 6. So we are adding. 4 plus 5 is 9. We cannot write 9 in base 6. Among the digits used in base 6, we do not have 9. So we have to change 9 to base 6 by dividing 9 by the given base, which is 6. And when you divide 9 by 6, you get 1, and the remainder is what? 3. So when you're writing down, you write the remainder, and then you carry the whole number to the next place value. So now we are adding 1 plus 2, 3. 3 plus 3, 6. We have said you cannot write 6 in base 6. Look at the digits used in base 6. We have 0, 1, 2, 3, 4, 5, but we cannot write 6 in base 6. So what do? We divide 6 by the base 6 to get 1 remainder 0. So we write the remainder and carry the whole number to the next place value. So now we add 1 plus 2, 1 plus 2, that is 3. 3 plus 4, that is 7. You cannot write 7 in base 6 because 7 is greater than the base in the question, which is 6. So you divide 7 by 6. 7 into 7, 6 into 7, that is 1, remainder 1. So you write 1, but since you have nowhere to carry the whole number, so you write it there. So that is the final answer, and the answer is in base 6. But you can conclude and say, therefore, 2 to base 5 base 6, 2 to 5 base 6 plus 4 3 4 base 6 is equal to 1103 base 6. So that is our final answer. I think you must have understood that question. So now let us go to the second example. Example 2. Example 2 is add 143, the base is 5, the base is 5, plus 11, the base is 5. Then in brackets we have answer in base 10. Answer in base 10. Yes. Now here you are restricted. You are restricted. They have said you add 143 base 5 plus 11 base 5. But the restriction is the answer should be in base 10. They want the answer to be in base 10. So now let us add first. So we go to that solution. Solution. So we are adding. That is 143. The base is 5 plus 11. The base is 5. So we are going to add. So remember the digits used in base 5. Let us identify the digits used in base 5. We have 0, 1, 2, 3, and 4. We cannot write 5 in base 5 because it is equal to the given base. And remember, you cannot use a digit that is greater than that particular base. So now we start adding. 3 plus 1, 4. Can we write 4 in base 5? Yes, because we have 4. Among the digits used in base 5, 4 is there. So that means we don't have to divide. That is 4. So now we continue. 4 plus 1. 4 plus 1 is 5. We cannot write 5 in base 5 because it is equal to the given base, which is 5. So what do we do? Then we divide 5 by the base, which is 5, to get 1 remainder 0. So we write the remainder and carry the whole number to the next place value. 1 plus 1, 2. Can we write 2 in base 5? Yes, because it is less than 5. It is less than the base, which is 5. So we can write 2. Remember, these are the digits that are written in base 5. So that means the instruction is answer in base 10. Your answer should be in base 10. That means you have to change 204 base 5 to base 10. Or I can say to decimal, because decimal is base 10. Now I'm going to change my answer to base 10 because I've been restricted to express my answer in base 10. How do we express in base 10? I said you draw a table. You remember that. This is my table. You draw a table, then you split the table. This is a 3-digit numeral. So into 3. Then I also divide this into 2. So that is my table. That is my table. Up I have place values. Up I have my place values of each of the digits. Then I have the numeral given below. Numeral given. Now, the numeral given, it is 204. The numeral given is 204. Now, since the question is in base 5, I'm changing 204 base 5 to base 10, so I'm using powers of 5. So 5 raised to the power 0, 5 raised to the power 1, and 5 raised to the power 2. I've expressed the place values in power form. So now I'm changing to base 10. So that means 204 base 5 is equal to, that is 2 times 5 raised to the power 2. That is 2 times that 5. Plus 0 times 5 raised to the power 1 plus 4 times 5 raised to the power 0. So now I continue. That is 2 times. The power on top determines the number of times the base has to be multiplied. The base is 5 raised to the power 2. So meaning that I multiply 5 2 times plus 0 times, any number raised to the power 1 is that number itself. So 5 raised to the power 1 is 5, plus any number raised to the power 0 is 1. So this is 4 times 1. So we multiply out. 2 times 5, that is 10. 10 times 5, that is 50. Plus 0 times 5, that is 0. Plus 4 times 1, that is 4. When we add all of that, we shall get 54, base 10. So, remember we are restricted. Number 1, they did not give us any restriction as to give our answer in a particular base. But number 2, they have given us a restriction. Answer should be in base 10. That is why after adding, I had to change my answer here to base 10. That is addition. Let me give you one more question and maybe I look at subtraction. So that example, I think 3 examples will be enough for you. Work out. Work out. Work out, that is 2, 3 base 7. 2, 3, the base is 7 plus 1, 2. The base is 7. Hey, let us look at that example. So now we go to the solution. Solution. That is 2, 3 base 7 plus 1, 2 base 7. Digits used in base 7, you write them aside. 0, 1, 2, 3, 4, 5, 6. So we are adding 3 plus 2, 5. Can you write 5 in base 7? Yes, you can write 5 in base 7. So I write 5. And 2 plus 1, 3. Can you write 3 in base 7? Yes, because 3 is less than 7. So that is our final answer. So it does not necessarily mean that for all questions you will have to divide. No, it depends. If you get a sum that is greater or equal to the given base, then you have to change that sum to the given base by dividing. So that is all with addition. Now straight away I'm going to take you to subtraction. I'm going to take you to subtraction of bases. So today we are going to do some examples and then we shall end with an activity to be done. So we are looking at subtraction now. So now we are looking at subtraction of bases. Subtraction. We are looking at a subtraction of bases. We have finished addition. So make sure you are very attentive and make sure the environment is very free from any disturbance so that you are able to understand what we are learning. Okay, now we are now looking at subtraction of bases. Straight away we go to our example, first example. 1 1 subtract, subtract 671 base 9, 671 base 9 minus 285 base 9. Yes, I understand some of you find this very difficult, but actually let me first, before I look at that very example, let me first take you to something you were doing in P1, P2, P3, P4 before they introduced bases to you. 1, we were subtracting in base 10 before they introduced bases to us. For example, if I have 9, 4, 2 minus 1, 7, 8. Yes, if that is it. Now let me take you back to P4. You are doing this subtraction, but the teacher did not tell you that actually it was base 10. Now it is the same idea that is brought here. Now let us first look here. This is your first arrange, that is 942 minus 178. We are going to subtract. Now 2 minus 8 is impossible. This is impossible because 2 is less than 8. So we move to the next place value. The next place value of tens, we borrow. We have 4 tens. When we borrow 1 10, we leave how many? 3. But we have taken a 10. You normally take 1, but that 1 you take contains 10. So when you add 10 to 2, you get 12. You added a 10. We take 1, but it contains 10. So that is 12. 12 minus 8, that is 4. We continue. You have 3 minus 7, it's impossible. So you move to the next place value of 100. You borrow, you have 9 tens. When you borrow 1, you remain with 8. But you have taken 1 10. When you add it to 3, you get 13. We normally add 1, but you have brought 13. So you add that 10 to 3, you get 13. So 13 minus 7. 13 minus 7, you are going to get 6. Now this one is possible. 8 minus 1 is 7. The reason as why I first brought you back to this idea before the bases were introduced is for you to get the picture of what I'm going to do. You borrow 1, but that 1 you borrow contains that particular base. Now this subtraction here was in base 10. That is why we borrowed 1, but 1 contained 10. Now we come to this work here. So solution. We are going to relate the same idea to what we have done there to what we are doing here. So now this is 671 base 9. 671 base 9 minus 285 base 9. So we are subtracting. Like we have been doing. 1 minus 5, you have 1 9 and 5 9s. 1 minus 5, is it possible? It's not possible. So you move to the next place value. But remember, you are dealing in base 9. So you have 7 9s here. When you borrow 1 9, you remain with how many? You remain with 6 9s. But you have taken a 9. So I have taken a 9. Why? I borrow 1, it contains 9 because I'm dealing in base 9. The question is in base 9. So 9 plus 1, 10. I think you must have understood this. So 9 plus 1, 10. 10 minus 5, maybe let me write here. I borrow 1. So when I add that, I borrow 1, but it contains 9. So that is 1 plus 9. I'll get 10. Let me do it like this. This is my side work. I borrow 1, that is 10. 10 minus 5, I get 5. So that means the answer here is 5. Now here I have 6 9s minus 8 9s. Now, 6 is less than 8. I cannot subtract. So I go to the next place value and borrow. So I borrow from here. There are 6 9s. When I borrow 1, I remain with 5. But I've borrowed a 9. I've borrowed 1, but it contains 9 because I'm in base 9. I've borrowed 1 9. Okay? So that is 9 plus 6. I get what? 15. Now 15 take away 8. I get what? 15 take away 8. I get what? So that is 7. So I write 7. You must be following. Now 5 minus 2. I get 3. So my final answer is 375 base 9. Now let me take you to the next example. I will give you more examples for you to understand me very well. Now I go to my second example. My second example is to subtract 1 base 2 from 1 base 2. Subtract 1 base 2, 1 base 2 from 1 base 2. So you are subtracting. So we go to the solution. So some candidates tend to confuse. They are asking to subtract this from this. So meaning you write this first. So that is 1. How many ones? There are 5 base 2. We are subtracting off 1 base 2. So that is what we are subtracting. Okay, we subtract. 1 minus 1, we get 0. 1 minus 1, 0. 1 minus 1, 0. There is nothing to subtract from 1, so we have 1 and we have 1. So that is base 2. That one has been very simple for us. So now, 3, we go to another question. So another question is going to be in base 9. That is 2, 3, 4. It is going to be work out. 2, 3, 4 base 5 minus 1, 2, 4 base 5. Okay, so that is what we are given to subtract. So that is 2, 3 solution. 2, 3, 4 base 5 minus 1, 2, 4 base 5. We are subtracting in base 5. So remember the answer has to be in base 5. So 4 minus 4, that is 0. 3 minus 2, that is 1. And 2 minus 1, that is 1. So our final answer is 1, 1, 0. The base is 5. So now, last example. I think the last example, most of you will have understood subtraction of bases. So now we have 2, 1, 3 base 5 minus 1, 3, 4 base 5. So that is the question we have. 2, 1, 3 base 5 minus 1, 3, 4 base 5. So solution. So we arrange. So that is 2, 1, 3 base 5 minus 1, 3, 4 base 5. That one that involves some bit of regrouping is what disturbs people. Oh, 3 minus 4. Is that possible? No, because 3 is less than 4. So we move to the next place value and borrow. We are in base 5. So we borrow 1, but that 1 we borrow contains 5 because we are in base 5. So 3 minus 4, impossible. So we move to the next place value. There is 1, 5. When I borrow it, I remain with 0. But I have taken a 5. I've borrowed 1, 5. So I've taken a 5. So that is 5 plus 3, because you formed there 3. 5 plus 3 minus what? Minus 4. So I get 8 minus 4, and that is 4. So that means here I have 4. Don't forget to indicate the base. So I move to the next. 0 minus 3 is impossible. So I move to the next place value and I borrow. There are 2 5s. There are 2 5s. When I borrow 1 5, I remain with 1 5. But I've taken 5. I have taken a 5. I borrow 1, but it contains 5. So that is, I add now, that is 5 plus 0 minus what I'm supposed to subtract off. So that is going to be 5 minus 3, which is 2. So I write 2 here. So 1 minus 1, that is 0. So meaning that my final answer is 2, 4 base 5. I think that is enough for today's lesson. Now I'm going to give you the activity for today. The activity for today, question 1, add the following, and that is 2, 4, is 5, plus 3, 4, is 5, plus 1, 2, base 5. Question 2 is 1, 1, 3, base 5, plus 2, 4, 2, base 5. I think you are realizing when the question is in base 5, I do not write a digit that is equal to 5, and I do not write a digit that is greater than 5. So C is 3, 2, 7, 4, base 8. 3, 2, 7, 4, base 8, plus 3, 4, base 8. Question that is D. That is 1, 1. That is 2. I can write this in brackets. 2, 4 plus 3, 3 plus 3, 0 is 5. Here there is another trick. The base is written outside the bracket, but this is just to confuse you. You just have to know, since this is outside, so that means everything here is in base 5. It has base 5. So you shouldn't get confused. So now we go to E. E, this is my last question of addition. So this is 2, 1, 4, 3 plus 3, 1, 4, 3 base 7. F, let me give the last one in base 2. That is 1, 0, 1, 1 base 2 plus 1, 1 base 2. So that is enough for addition. Now subtraction. Number 2 is subtraction. Subtract the following. Subtract the following. That is A. 3, 4, 2 base 5 minus 1, 3, 4 base 5. Part B, 4, 4, 4, 2 base 7 minus 134 base 7. So number 2 is subtraction, and number 1 you do addition. So we continue with number. We go to part C. Part C is take away 643 base 10 from 914 base 10 D 7 E. So we need a lot for subtraction. Some people would be saying, Mr. Kimuli is giving a lot of work. The math is practice. The more questions you try, the more you perfect in what you're doing. So minus 164 base 7. So now, that is the activity for today. And I believe for those examples I've given you, you must have understood this lesson. You know, mathematics is interesting, and you must enjoy it as you work it out. It is a very good subject, and once you do it well, I assure you, everything of yours will be okay in the future. So now, do this work. So after doing this work, make sure you go through it, and it will be presented for marking. Thank you for watching this lesson. I remain Kimuli Robert from Kampala Junior Academy.